Hi, and welcome to AWS Innovate Online Conference. Thanks for joining me today. My name is Anand Iyer, and I'm a Principal Solutions Architect. If you're interested in learning how companies like Amazon and Netflix release code changes every 11.6 seconds, you have just joined the right session. In this session, I'm going to explore how you can increase release velocity in the context of a complex environment. And I'm not just talking about spinning up a Jenkins on a big X1 instance. This is a 400 level session, so I'm expecting that you know what continuous integration, continuous deployment is, and are fluent with basic AWS concepts like accounts and VPCs. Doing continuous delivery in fast, complex enterprise environments is hard because you need to deal with numerous teams, environments, accounts, and VPCs. If you don't configure deployment pipelines the right way, you will be less secure and you will have lower release velocity. We see enterprise customers rapidly expand to having dozens of accounts, and as their footprint in AWS expands, the speed of getting changes out the door drops in situations where pipelines are not set up according to best practices. To set the foundation, I will walk through some multi-account topologies as well as some best practices, and then we will look at how you can run pipelines across environments in a way that is fast and doesn't get bogged down by all the environmental complexities. And then I've got a little demo for you. But first, I want to discuss some of the challenges we commonly see in doing complex continuous delivery. As customers mature, they often find it hard to coordinate across teams. Modern agile software development is all about having teams set up in a way that doesn't create blockers, but there is still significant need for alignment to ensure that your software applications have consistent ways of interacting. This coordination across teams is hard, especially when you have teams affected by a single deployment pipeline, multiple teams. How do you handle changing a pipeline when one team owns the dev and test environments and another owns production? The environment itself becomes complex. How do you manage secrets consistently across multiple accounts and environments? It's often seen as a challenge. What about making decisions about where a pipeline lives when you have got multiple teams using multiple environments that are all related? And change control processes slow things down. These processes are often more pertinent to mutable infrastructure, as change is treated as a significant event rather than part of a regular process defined in code. If you don't deal with complexity front on, you will suffer from deployments slowing down. And as we all know what that means, your business is changing more slowly because your software is changing too slowly. These are issues, but let's walk through how customers often arrive in these situations. When you start on AWS, it will generally be a single technical person testing out the platform, kicking the tires, so to speak. So a single account will be created. This might be a POC, for example. And a project will be agreed on, and a proper account structure will be set up, generally broken down by environment. This usually means one production account and a non-production account. Small businesses often stop here unless they set up a sandbox account with a good tagging strategy. As an enterprise matures, however, we usually see our customers creating one account per environment. These patterns will be replicated out across business units. None of this is rocket science, but I wanted to set the scene before we need to explore where deployment pipelines fit into this. Before we get to the pipelines, though, we need to explore their scope. Let's look at how application architecture has evolved. There will be lots of people still working in large enterprise corporations on a single code repository, which gets built into a single app with a single database behind it. The app will take longer to build, and each change will have a large merge being done, as well as a lot of well-coordinated integration testing. This means that the scope of any change is very large, as there is a load of business functionality that's involved in any one application change. If you fix a typo, you have to rebuild and deploy the entire application. This makes changes slow, and therefore your release velocity will be slow. In service-oriented architecture, or SOA, your app is broken into services, which will often have multiple teams working on different aspects of them. This means that services are smaller and less risky than monoliths, but they still have the same coordination, and changes have a fairly large scope. This is more common in enterprises and is a good way to manage change, as you often won't have microservices. With microservices, the best way to make change is to have a delivery pipeline for each microservice to ensure that all changes are isolated from changes occurring in other microservices. In applications that have been built in a cloud-native fashion, this is what we currently consider best practices. Using these decoupled patterns helps you increase your release velocity, as it reduces the dependency for each individual change. This means that changing one microservice won't impact other microservices, so you can release as often as you like. Another good practice is to move towards independent data stores for your microservices, as it decreases the dependency on coordinating with other teams and makes any one team more autonomous, and that means faster. So the lesson here is smaller pipelines go faster. Now that we have a feel for how to define the scope of a pipeline, let's look at their relationship with environments and accounts. What we often see is customers setting up one pipeline per account. Now this sounds sensible, as it respects the boundaries which an account is designed for. Who has a design like this? The issue is that it also means that you get drift in the definition of these pipelines. Using AWS CloudFormation is a good practice for defining your pipeline in code, but we still see customers creating different templates for different environments. The problem with this is that when you define the change process differently for each environment, you are going to get different results. As you move across environments, you're not building confidence as you promote code changes through the environments. You are using different build artifacts for different environments, and you are getting slowed down by the need to process this once for each environment. We are starting to consider this as a bit of an anti-pattern, as we see customers struggling with this. A better way to set this up is to have a pipeline that resides in your development or production environment with different stages for different environments. Who has this sort of a design? This means that changes being made to your app, service, microservice is visible in one place. You can visualize the entire software development lifecycle. Of course, you want to store it in code, and you want to ensure that the right people have the right permissions to change it. Setting things up this way will increase your release velocity, as everyone can see what's happening to code changes as they pass through the environments. This means that you don't need to coordinate across team members and don't need to manage multiple pipelines. The downside of this approach is the lack of environmental isolation. If your pipeline is defined in a dev account, those accounts tend to be little lighter on security. So you have the risk of a bad actor introducing malicious code into the pipeline that can be pushed in production. And if the pipeline is defined in production, it is too hard to access to change the earlier stages of the pipeline. So, although this pattern will increase your release velocity, it isn't ideal from a security perspective. So what is the best practice? Well, we are seeing customers having a lot of success with sticking DevOps tools like continuous delivery pipelines in their own account. The pipelines in this account can assume cross-account roles to access resources in the dev, test, and production accounts. This imposes best security practices as well as operational practices in how you define your pipelines in the code and how you manage the end-to-end flow of your changes to your application. But that account can host other things too. Business units would have their own sets of accounts, a continuous delivery account, and a dev, test, and production account. Inside the continuous delivery account, each app, service, microservice would have its own delivery pipeline. In a large, complex environment like this, over time, you're likely to have some centralized services. So these accounts would be run by the Cloud Center of Excellence teams. Ideally, developers would have their own sandboxes and be granted some budget to build with. A great way to speed up the provisioning of resource changes to these developer sandboxes would be to use CloudFormation stack sets. With stack sets, you can define an AWS resource configuration in a CloudFormation template and then roll it out across multiple AWS accounts and/or regions with a couple of clicks. But how do you technically achieve this? I'm glad you asked. AWS Organizations comes to our rescue here. Organizations lets you set up all your other accounts more easily. It automatically consolidates your billing for all accounts you create with it. As a development team, you can quickly get access to dedicated AWS accounts with the correct corporate controls so that resources are isolated and development timelines are maintained. It gives you scripted account creation and inheritance of service control policies, which are things which control which accounts have access to what APIs in the AWS cloud. To set up organizations, you need to create an organizational unit, or OU. As you can see, I have created one called Alien Gaming Republic to represent the gaming company's dev team for their game, Docker Invasion. But more on that later. Inside the OU, you can see the 3 accounts we are going to be using: the DevOps account, where our pipeline will live, and the dev and production accounts. You need to set up a policy to allow the master account to assume a cross-account role in the other accounts. So in our case, that's the organization's master accessing our DevOps, dev, and production accounts. This is what the policy looks like. I know it looks like we are diving into security stuff here, but I want to show you how to get the foundation set up. So let's look at AWS developer tools that help you improve the release velocity. AWS Code Commit is a fully managed source control service that makes it easy for companies to host secure and highly scalable private Git repositories. AWS Code Build is a fully managed build service that compiles source code, runs tests, and produces software packages that are ready to deploy. AWS Code Deploy is a service that automates code deployments to any instance, including EC2 instances and servers running on-premise. Finally, we need a pipeline to orchestrate this workflow. So AWS Code Pipeline is a continuous integration and continuous delivery service for fast and reliable application and infrastructure updates. So Code Pipeline builds, tests, and deploys your code every time there is a code change based on the release process models you define. AWS Systems Manager provides a number of great tools to help you manage fleets of EC2 instances. Many applications traditionally have needed to change over time by getting patched and having the operating system upgraded. So we call this mutable infrastructure. The problem with mutable infrastructure is that in enterprises, it often needs to go through a change management process, which usually slows your release velocity. We are seeing more and more customers move towards immutable infrastructure, which is designed to replace existing infrastructure assets with new ones that already have been upgraded. Parameter store is great for storing secrets that need to be dynamically injected into immutable infrastructures. So in this presentation, we'll focus on the parameter store. Parameter store lets you store configuration information and even secrets in a place that's secured by AWS Key Management Service, KMS, and is easy to interact with. It natively integrates with a number of AWS services, so it's easy to use, and so it's created for cross-account configuration management. It also is capable of sending notifications when something changes, so you can hook automation into it to trigger updates to your environments. Our demo application is a game called Docker Invasion. It's comprised of 2 microservices, all of which have different compute technologies powering them. The main game service runs in a Docker on Elastic Container Service, ECS, and the service which tracks the top score across game sessions. That lives in a Lambda function. The goal of the demo is to give you a quick feel for how you can orchestrate different technologies across accounts so that you can release quickly. Let's look at the game microservice in detail. In the DevOps account, we have used the code pipeline service, and in step 1, the developer makes a change, checks it in to the code commit. In step 2, it triggers a code build and generates a Docker that gets registered in the Elastic Container Registry, ECR, as shown in step 3. In step 4, the code pipeline assumes the deployment role, and steps 5 and 6 invoke the CloudFormation service to create the ECS cluster. Finally, in step 7, the task definition from ECS pulls the game microservice Docker image that we created in the Elastic Container Registry, and then it deploys it to the ECS cluster. You want to ensure that there are some sanity checks in place before deploying to production. After all, we don't want to set things on fire. And you can use Black Day deployments to only allow promotions to production at certain time windows, or have it automatically promote once some synthetic tests have been run, or just have good old manual approvals in place. For our demo, we are using a simple approval, but if possible, you should try to configure your pipeline to automatically clear the gate based on some good criteria that works for your business. We repeat the same steps for the production account. In steps 8 and 9, we assume the production deployment role and then invoke the CloudFormation to create the ECS cluster and deploy the Docker from ECR. Now let's take a look at the deployment of the top score microservice. The top score microservice keeps track of scoring counter across sessions, and it's implemented as an AWS Lambda function. The top score values are stored in a DynamoDB database. The team working on this service checks in the code, which again triggers a build and packages the Lambda code, but this time it does it as a zip file and uploads it to the S3 bucket. The service uses AWS Lambda, so I wanted to show you that architecture will work for any different sets of services you are using. Lambda will use a cross-account role to hit the parameter store to retrieve the endpoint information for DynamoDB. This in turn will use KMS to decrypt the data. Note that a new token will only be retrieved when a new container is provisioned, so it won't spam the parameter store every time you run a function. Now, you do need to be aware of the service limits hitting parameter store each time though. The final deployment to the production account is fairly straightforward, and it follows a similar pattern as we did with the game microservice. So it's time to see all of this in action. We'll log into the familiar AWS console and take a look at the Docker Invasion application. At the top left-hand corner, you see the score counter, which is maintained by our score microservice. As we showed in the previous slide, an AWS Lambda function keeps track of the scores as we fire and kill invading Dockers until one of them obviously kills us. To see our pipeline, let's hop on to our code pipeline service. The alien pipeline service shows the various stages we have defined for commit, build, test, and deploy. The source stage has the AWS code commit as the source repository. The build stage uses the code build service, and after our build completes, we use the deploy dev stage to deploy the microservice using a CloudFormation template. Finally, the deployed prod stage defines a manual approval step. To test our pipeline, the first thing we need to do is make a code change and check it into the repository. So we are going to do that by changing the game.js file and changing the background color. So here we are changing the background color from black to amaranth. We save the file and then execute the git command to check in the file to the code repository. We also provide a comment there which says bring the party, so we exactly know what changes we made. And we run the push command to push the particular change to the code commit repository. As soon as the repository is changed, our pipeline kicks in and the source stage changes status to in progress. So you'll see that the particular status has changed, And at this point, the code commit repository has synced and identified the changes in the game.js file. Notice the comment, bring the party, is displayed under the source tag. And after this stage completes successfully, the build stage is invoked. As you can see, the progress has changed, the status has changed to in progress, and the code build service is now building the code. While it builds, let's go and inspect the code build project definition. And we have a build alien project created that points to the location of the code in our repository. Under the project details, we see the build specification YAML file, which lists the actions to be taken after the build process. So while that comes up, let's view the actions there, and there you go, the build spec file has opened and we are seeing the various actions. The docker build command builds the Docker image from a Docker file. The docker tag command creates a tag, and obviously tags are a great way to identify images in the repository and really are good practices. Recollect that once we build, we want to create a Docker, and the docker push command does that for us. We get that particular file out of the way, and let's hop on and look at the code build status. And yeah, so it's great. So our build has completed, and we are going to go take a look at the container registry. So it should have moved our particular build, the container, the Docker, to the container. Now in the deploy dev stage has passed the JSON YAML file to the CloudFormation template to provision the necessary Elastic Container Service infrastructure to deploy the Docker, and that also completes. So at this point, we have our Docker created, and it's been in fact deployed in ECS. And now we are ready to test our changes in the development account. So we have a manual approval step here. You are looking at the email. So we have hopped onto the email. We have received an email for approving this particular change, and we are testing the load balancer URL. So we see that the background has changed here, and we have amaranth color showing up. The step asks the approver to enter a comment and hit approve. Our manual approval step is now completed successfully, obviously after we hit approve here, and it has been moved to the next stage in the pipeline, which is deploy to prod. Again, this step repeats the same series of steps that we created earlier, but this time all the resources are being created in the production account. As you can see, the resource provisioning is still happening. It's going, it's in progress in deploy, and it should quickly turn to successful, so we can test our changes. While the changes happen, basically all of these resources now are being created in the production account. So we have successfully done that. We are going to test the production URL, and as you can see, we will just quickly hit a refresh here. We do a quick sanity check of the application, and we are good to go. The background has changed, and our firing nozzle also works pretty well. So that was the game microservice, the one that builds out the Docker. We also have the top scorer microservice that updates the score across sessions. Taking a look at the pipeline for this microservice, we have a similar structure. We have source, build, deploy to test, and deploy to prod after a manual approval. Let's take a closer look at the build specification for this microservice, which is basically packaged as a Lambda function. Let's scroll up and take a look at that. We will open the build specification. We open the build project. We drill down to view the build specification here. The build command shows how the S3 bucket where the Lambda function is packaged and stored. Look at the build specification. As you can see in the build specification, we have the command, and within the command we also have the location of where the particular Lambda function is going to be stored. That's the S3 bucket location. Let's open up the particular Lambda function implementation, and while I look for my Lambda function, oh, there it is. And this is basically importing the Boto library, and the first few lines just show assumption of a role for reading from the SSM, the systems manager, we get a systems manager variable, and then we get the parameter, the production table, which is the name, the store from the store that we get. That's the DynamoDB table name, and from the DynamoDB table, we get the value for the top score. I hope from the demo you got a good understanding of the pipelines that were implemented for both the microservices and now feel well equipped to do fast deployments in your projects. So recapping the presentation, we looked at including dev, ops, and infosec in the account strategy, using a separate account for DevOps, and leveraging cross-account roles to coordinate deployments across accounts, thus enabling building once and deploying many times. If after today you wanted to take your AWS knowledge to the next level, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And remember to validate your technical expertise with AWS certifications. AWS also has a wide partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. Learn more about how APN partners can help you find the right APN partner for your needs. You can visit the AWS APN booth at our showcase. I hope you enjoy the rest of the AWS Innovate online conference. Do take time to provide feedback on today's event so we can improve the event experience for you in the future. And have a good day.